Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how you can find the concentration of the ion that is left after you have selectively precipitated that ion out. And so in the previous video we were dealing with this example of seawater having magnesium and calcium, and we were given a certain amount of magnesium and calcium in the seawater. And we were asked, what is the minimum amount of hydroxide ion of the KOH that you would need in order to precipitate out the magnesium? And we found that minimum amount to be 1.9 times 10 to the negative 6 molar. So, so that is the minimum amount of OH we would need to start to precipitate out the magnesium ion. And then now this question is asking, as you add more and more hydroxide ion to precipitate out more and more of the magnesium, at some point you are going to start to precipitate out your calcium ion. And so the question is, how much of the magnesium ion is left as soon as you get to the point of calcium starting to precipitate out? So the first thing you're going to want to do is find the minimum OH concentration that you would need to start to precipitate out the hydroxide ion. So that's the first thing we need to do. And we're going to do the same thing we did before when we wanted to find the minimum for magnesium. So you have to have the KSP of the salt. So in this case, calcium hydroxide. So the calcium hydroxide, and set that equal to Q, because that's the bare minimum of when your salt is going to precipitate it out, is when Q is equal to KSP. So what is the Q value of calcium hydroxide? That is 4.68. 4.68. Let me rewrite this. So 4.68 times 10 to the negative, I want to say it was negative 6. Negative 6. And that's going to be equal, we're going to set that equal to Q. And then the quotient, again, for the quotient, that's going to be the same expression as KSP, but we're going to be using the concentrations that they gave us here. So the formula for calcium hydroxide is CaOH2 solid, and when that dissolves, it's going to become Ca2 plus aqueous plus 2OH minus aqueous. And so the quotient expression is going to be the concentration of Ca2 plus multiplied by the concentration of OH minus squared because of the two coefficients. And so now we're trying to find the minimum concentration of OH. So all we need to do is plug in the concentration of Ca plus that they gave us, 0.011. So that's going to be equal to 0.011 times the concentration of OH minus squared. And now all we need to do is solve for the OH. So when we do that, the OH concentration is 2.06. That's going to be equal to 2.06 times 10 to the negative 2. And double check. And we're putting a line under the 0 to mark that this is our last sig fig. So we're only allowed 2 sig figs because we have 2 sig figs here. Okay. We're keeping an extra one to avoid rounding errors. Okay, so now we have the minimum concentration that we need of OH minus hydroxide ion in order to start to precipitate out the calcium ion. And so, but the question now is, how much is left at this concentration of OH? So what we need to do now is go back to the Q value for magnesium and see how much magnesium is left. So now we go back to magnesium. So again, magnesium, hydroxide, the equation is, so we have solid goes to Mg2 plus, aqueous plus 2 OH minus, aqueous. And so here, what we want to find is we're going to set the KSP again. Okay. And we're going to set that equal to the expression for KSP. And so, so the KSP for the magnesium, let's see that again. So the KSP for magnesium is going to be 2.06. So 2.06 times 10 to the negative, I want to say 13. And then we're going to set that equal to Q for this value here, this equation here for this reaction. And so the Q expression again is going to be the concentration of magnesium multiplied by the concentration of OH minus squared again because of the 2 coefficient. But this time, last time we plugged in the value of the magnesium concentration to find the minimum concentration of OH. That was the last video I did. But this time we want to find the minimum amount of magnesium that's left at this concentration of OH. So what we're going to do is that's going to be equal to magnesium 2 plus, and now we're going to plug in this value, 2.06 times 10 to the negative 2 squared. So then what happens is we're going to then solve this equation for the concentration of magnesium. And when we do that, we get 4.9 times 10 to the negative 10. So here we have the magnesium 2 plus. The concentration is equal to 4.9 times 10 to the negative 10 molar. Let me double check that. 4.9 times 10 to the negative. All right, so this here is the remaining concentration left when the calcium starts to precipitate. And this is impressive because you can see this is what remains. This is what we started with. So the selective precipitation worked really well because you were able to precipitate out 99.99% of your original amount before the calcium starts to precipitate out. And so you were able to remove almost all of the magnesium before you started precipitating out the calcium. So that's a really good selective precipitation occurring. I hope this helps. I hope this video made sense, and I hope you enjoyed it. If you like my videos, please like, share, subscribe, hit the notification bell, and leave a comment in the comment section. Thanks for joining me. I'll see you next time.